Welcome to the heart of Lockheed Martin's Fort Worth facility, where the world's most advanced multi-role fighter jet begins its journey through a symphony of engineering. Stretching across a mile of production floor, this assembly line represents the pinnacle of human ingenuity, combining massive scale with microscopic precision in every single detail. Here, heavy machinery moves with the grace of a dancer, as automated systems transport essential components to their precise locations without a single second of wasted motion. Every movement is calculated by sophisticated algorithms, ensuring that the thousands of parts required for each aircraft arrive exactly when and where the technicians need them most. The process begins with the raw strength of titanium, carved by high-intensity lasers that slice through hardened metal with a level of accuracy measured in mere micrometers. As the sparks fly, the foundation of the Lightning II is forged, creating structural components that can withstand the extreme stresses of supersonic flight and high-G maneuvers. Skilled engineers oversee every phase, utilizing massive, three-dimensional digital twins to verify that the physical build matches the perfect digital blueprint designed by the world's best. This digital integration ensures that every bolt, wire, and panel fits perfectly, eliminating errors before they can happen and maintaining the highest standards of aerospace quality control. In the specialized cleanroom, the focus shifts to advanced materials. Robots delicately layer carbon fiber sheets to create the aircraft's incredibly strong yet lightweight external skin. These composite materials are the secret to the F-35's performance, providing a high strength-to-weight ratio that traditional aluminum structures simply cannot match in modern aerial combat. The automation allows for perfect consistency across the entire surface of the wing, ensuring that the aerodynamic properties are identical for every aircraft that leaves the line. Human touch remains vital, as expert technicians inspect every inch of the composite layup, ensuring there are no wrinkles or imperfections that could compromise the jet's integrity. This meticulous attention to detail is what defines the F-35 program, where even a microscopic flaw is caught and corrected by the world's most experienced aerospace craftsmen. The finished layups are then moved into the autoclave, a massive pressure cooker that uses intense heat and pressure to bond the composite layers into a single piece. Under these extreme conditions, the resin cures and the carbon fibers fuse together, creating a structure that is as hard as steel but significantly lighter than aluminum. Precision sensors monitor the environment inside the chamber every second, guaranteeing that the chemical transformation occurs exactly according to the strict engineering specifications for flight safety. As the cycle completes and the doors open, the wings emerge. They are now transformed into rigid, high-performance components, ready to take on the forces of flight. The resulting structures are masterpieces of material science, designed to be nearly invisible to radar while carrying the heavy loads of weapons and fuel during long missions. Every edge is sharp, and every surface is smooth, meeting the exacting aerodynamic requirements that allow the F-35 to maintain its stealth profile at supersonic speeds. We move to the mate station, where the forward, center, and aft fuselage sections are brought together to create the recognizable silhouette of the F-35 Lightning II. This is a critical moment in production, where massive components must align with incredible precision to ensure the structural integrity and aerodynamic balance of the entire aircraft. Advanced laser alignment systems scan the structures, providing real-time data to computer-controlled jacks that position the heavy modules with sub-millimeter accuracy for a perfect fit. The system ensures that the airframe is perfectly straight, which is essential for the flight control software to operate correctly and for the stealth characteristics to remain effective. Once aligned, the robotic drilling begins. These machines are programmed to drill thousands of holes through multiple layers of different materials with unwavering speed and consistency. The drills penetrate the advanced alloys and composites, creating perfectly clean holes that are ready for the specialized fasteners that will hold the entire jet together. There is a rhythmic beauty in this mechanical process as the excess metal is cleared away, leaving behind a structure prepared for the final stages of its construction. Robotics allow for a level of speed and repeatability that would be impossible for humans alone, drastically reducing production time while simultaneously increasing the overall quality. Following the robots, skilled technicians install specialized fasteners by hand, and using power-assisted tools to ensure that every single connection is tightened to the exact torque required. Each rivet is a critical link in the chain, designed to maintain its hold under the intense vibrations and thermal expansion experienced during high-performance combat flight missions. The result is a seamless outer mold line, which is crucial for both reducing drag and minimizing the radar cross-section of this fifth-generation stealth fighter jet. Quality assurance is constant. Every fastener is checked and verified, ensuring that the aircraft meets the zero-tolerance standards required for the United States Air Force and its allies. Now we witness the installation of the heart of the machine, the Pratt & Whitney F135, the most powerful fighter engine ever integrated into a production aircraft. This massive power plant is capable of producing over 40,000 pounds of thrust giving the F-35 the ability to reach supersonic speeds and carry heavy combat loads. The engine is guided into place with extreme care as the mounting points must align perfectly to transmit the massive forces of thrust directly into the airframe's core. Once seated, the complex network of fuel lines is connected. These systems must deliver high-pressure fuel reliably, even during the most violent maneuvers in the heat of battle. The digital brain of the engine is then linked to the aircraft's main computer, allowing for precise control of every aspect of combustion and performance during flight. Hydraulic systems are also engaged, providing the power necessary to move the massive control surfaces and the thrust vectoring nozzle found on the specialized vertical landing variants. Engineers perform internal inspections using fiber optic cameras, peering deep into the turbine sections to ensure there is no debris or damage before the engine is ever started. Each blade is a work of art, forged from advanced alloys and coated with thermal barriers to survive the thousands of degrees generated in the heart of the engine. With the final bolts tightened to exact specifications, the engine is fully integrated, providing the raw power needed to dominate the skies for decades to come. Next, we enter the cockpit, the nerve center where the pilot becomes one with the machine through a revolutionary suite of avionics and electronic systems. The traditional gauge cluster is replaced by a single, massive, panoramic touchscreen, providing the pilot with all the mission-critical information in a highly intuitive format. This advanced interface allows for unprecedented situational awareness, fusing data from all sensors into a single, easy-to-read picture of the entire battlefield environment around the jet. Behind the screens, miles of high-speed fiber optic cables carry data at the speed of light, connecting the sensors, computers, and weapon systems into a unified network. The organization of these wires is a testament to the engineering discipline required, ensuring that every system remains accessible for maintenance and protected from electrical interference. The life support systems are installed next, including the high-performance ejection seat, which is designed to safely launch the pilot away from the aircraft in any emergency. This seat is a complex machine in its own right, equipped with its own rocket motors and stabilization systems to protect the pilot's life at any altitude. The controls are positioned with ergonomic perfection, allowing the pilot to command the aircraft with minimal physical effort, even during high-G maneuvers and complex tactical situations. Every switch and sensor is tested multiple times, ensuring that the interface between the human pilot and the digital flight computer is flawless and reliable for every mission. The aircraft now enters the most secretive part of the process, the application of the radar absorbent material, or RAM coating, that grants its stealth capability. Advanced robots apply the coating with extreme precision, ensuring that the thickness is uniform across every square inch of the aircraft's surface to maximize its invisibility. This coating is designed to absorb and dissipate radar waves, preventing them from bouncing back to enemy receivers and keeping the F-35 hidden from hostile detection. The finish is so smooth that it also reduces skin friction, helping the aircraft move through the air more efficiently and reach higher speeds with lower fuel consumption. Precision instruments verify the coating's properties, as even a minor variation in thickness could increase the aircraft's radar signature and compromise its tactical advantage in combat. With the stealth coating complete, the national insignia is applied, marking this machine as a defender of freedom and a symbol of American air superiority across the globe. The transformation is complete. What started as raw titanium and carbon fiber is now the most lethal and technologically advanced fighter jet ever built by mankind. As the hangar doors open at dawn, the F-35 prepares to leave the factory for the very first time, moving toward the runway for its maiden flight. It rolls out onto the tarmac, a silent predator ready to unleash its power. The ground crews perform their final checks as the pilot prepares for takeoff. With a thunderous roar, the F-135 engine comes to life, its afterburner pushing the aircraft forward with incredible force, shaking the very air around the runway. The Lightning II takes to the skies, a masterwork of modern engineering, ready to defend the heavens and define the future of aerial warfare for generations.